So with these words, I request Dr. Shankar K, coordinator of this workshop, to introduce our session one speaker, Professor Vivekananda.
Good morning, everyone. I am very happy to introduce today's technical expert session, Dr. Vivekananda. Dr. K. Vivekananda has been working in Pondicherry Engineering College since 1992 and currently is a professor in the Department of Computer Science. He obtained his BE degree from Bharatiyar University in 1996, MTech degree from Indian Institute of Technology, Bombay in the year 1991, and PhD in 2005 from Pondicherry University. He is also an IBM certified database associate for FDP. Dr. Vivekananda, before joining this institution, served as scientific assistant at KBSE's Project Indian Institute of Science, Bangalore, and project engineer at IIT Bombay, and research committee member in Central Research Laboratory of Bharat Electronics University. In his more than 2 decades of experience, Dr. Vivekananda has been serving in other capacities such as chairman, convener, expert member of different committees constituted by government agencies, organizations, and organizations. Professor Vivekananda has published and presented more than 100 research papers in different reputed international and national journals and conferences. Even though Dr. Vivekananda is he is passionate in software engineering, object-oriented systems, information security, and website systems. We feel very happy to have Dr. Vivekananda as an expert for this technical session of this ATAL FDP, role of artificial intelligence in science, conducted for CBSE school teachers.
Hello, sir. There is more echo.
Now I hand over the session to the session. Please, sir.
Yeah, thank you, Dr. Shankar, sir. All of you, please mute your mic. Hopefully, we will not be hearing the echo again. Okay. All of you, please mute your mic. If everybody mutes the mic, the audio will be clear. Yes. Is it now echoing? Is it echo now? Is it echoing now?
Sir, it is perfect.
Now it is not echoing, sir. It is good.
Okay. We will start the session. I'll project the PPT. Dr. Shankar, sir, how much time should I have to go?
Sir, you can take 1 hour, 1.5 hour. No problem.
Yeah, okay, 1 to 1.5 hour. 1.5 hour means 1:30. Okay. Sir, okay, I'll now project it. Let me see, it's working. Share. 1 minute. I'll just come.
So we can.
Yeah. I'm starting. Yeah. I'm starting. Sharing. Is it? Yeah. Is it sharing? Would you be able to see? All of you, please mute.
Yes, sir. Your screen is visible.
Okay. Am I audible?
Yes, sir. You're absolutely audible.
Yeah. Please, all of you, please mute your mic. I am getting a lot of noise. Please mute your mic. All of you, please check. Yeah. All of you, please check. Mute your mic. Okay. Now you could see this thing. Yeah. Still, some more people need to mute. Yeah, please check. All of you, please check. One of you have not muted the mic. Hello. Please, all of you mute. Yeah. Okay, now it is very clear. Maybe I may take 1 hour. Okay, I don't want to barge into your lunch time. So this one, I try to finish it within 1 hour. Now, really, it's a very, I congratulate the organizers for arranging such a wonderful program for school teachers, right? They in fact, a person can be made intelligent by the school teachers. We can only enhance whatever they have done it. And especially, I have great regard for all the school teachers, especially the CBSE school teachers. Because in the state board schools, they taught us how to memorize it. But at that time, you used to teach how to understand the subject, right? But nowadays, even the state board syllabus is also following the methodology which you have adopted. So, it's really a very nice program that all of you will be knowing the artificial intelligence. Okay, about artificial intelligence. So let us take one by one. Now, what is our agenda is, we will see what is information technology, evolution of information technology, what is artificial intelligence, AI applications in various sectors, and future trend in AI. Okay, these are the points which we are going to cover. So, in fact, I have seen your timetable. In detail, they are going to take what is artificial intelligence, what is deep learning, what deep learning using Python, applications of artificial intelligence, applications of deep learning. So a separate session is allocated. Maybe you can think this as an overview of all those things. Okay, so individual insight or learning might take place in the other sessions, which I try to give a bird's eye view on all the things. So let us see that what is information technology. Information technology is use of computers to store, retrieve, transmit, and manipulate data or information. Information technology is typically used within context of business operation as opposed to personal or entertainment technology. But nowadays, this also it covers. The IT also covers personal and entertainment technologies. When we say store, retrieve, transmit, we can also talk about all the devices which are used for communication also. So it includes everything. We can call that information technology. Sometimes we will call also information and communication technology. Okay, so together we represent as a one thing, and we try to call now that as a information technology. Now let us take what is how it has evolved, how information technology has evolved. It can be divided into 4. In fact, there are various methods of classifying this, but this one I liked it. It is also really representing very nicely, right? So 1960 to 80s, your major theme is industrial automation. And 1990 to 2000, it is a business process automation. Okay, so first one is used for industry. Next is the business process. And after that, there is a digital transformation. Everywhere, digital data, everything is seen as a digital information, and how it can be transformed so that it will be useful for the mankind, or business people, or industry people. So that is the theme of the third step of evolution. Okay, and fourth step, the current step which we are is intelligent enterprise. Okay, it's the intelligent enterprise. Now you can see that the artificial intelligence has completely a new step, new phase for evolution. You can understand the importance of the artificial intelligence. You can understand the importance of artificial intelligence. It's the fourth phase or the current phase is called as intelligent technologies. Major idea is intelligent technology and theme is intelligent enterprise. Instead of directly going to intelligent technology current theme, we quickly go through some of the things which are available, which are some of the things which are available in the previous steps of the evolution. All of you will be knowing all these things, so I quickly go through that. In the first phase, if you mainframe and PC, transistor and silicon revolution. Okay, so basically for all this information technology revolution started with the transistor, invention of the transistors. What you can see in the first diagram, first picture is the transistors, and that they are fabricated separately. After that, the transistor is put into a chip, right? Transistor is put into a chip that really has again made a growth in the information technology. So if you take any processors, okay, all that Pentium processor, I-core processors, okay, all those processors, if you take, all those processors are having only the transistors. The more number of transistors you can include in a chip, more computation you can achieve it. So that's why we have got LSI, VLSI, all those terms have evolved based on the number of transistors which we can put it in a single IC. So that is the first step of evolution. Okay. Next step is this, in fact, lead to computers, invention of a computer. But the computers was a mainframe computers. It is a very big in size. Even it occupies one big room. So all those things were there, and the terminals are connected and people were using it, right? So this is what people were using it for, all that industry or business, something they were using it, right? But in the course of time, we have also got PCs. In fact, this you can see that is a 1980s PC, right? With all floppy drive, line printer, everything it is there. In fact, you cannot see the floppy disk at all. If you ask the generation, they will be, if you have seen floppy disk, they will not be knowing that. Whereas we have handled two different sizes of floppy disk. So it has evolved. The next step is the invention of small computers. Okay, in fact, the big computers was invented early and followed by the small computers. So availability of small computers make everybody to buy it and use it for that purpose. Okay, so that's what they call it as a these things, emergence of PCs, and also the industrial things are got plants are automated. Okay, industrial plants are automated. So transistors in plant floor automation, you can see that the entire process can be captured, can be controlled from the control room. So that kind of computation and has been found out and is being used. That is the first phase, mainframe and PCs. Now we go to the next phase, client server and internet. If you see that widespread PC adoption, people started developing many such PCs. Everybody wants to have one. Everybody wants to have one, and they are adopting all those PCs for their work. And in fact, you can see this slide, how many people are having the percentage of the people are having the computers in United States starting from 1975-6, whereas here you can say some 55% or something they have here. Okay, so this is a widespread PC adoption. Next, of course, we have another major revolution which have come is the internet. Okay, the internet, the availability of internet makes it possible to connect computers throughout the world. One computer can access another computer in a short span of time. from the sitting at home itself, I can see what is happening at somewhere else. So all those facilities are possible by the broadband internet. And next, again, in the business side, if you take enterprise resource planning, right? So it is when you are now talk of the whole enterprise, starting from manufacturing and delivering, starting from delivering, creation of invoice, obtain of raw products, computation of salaries, computation of working hours, the whole enterprise, whatever the business process, we call all these things as a business process. Computation of salaries, computation of invoice, printing of invoice, generation of report, ordering of raw material, all these things we call it as a business process. All this business process are we could able to put it in a centralized place and able to control it. Okay, so this is a growth of the second phase. And also please understand that we have got client server concept. All of you know that client is a machine, is also a computer machine. Server is also a computer machine. Client machine always asks something to the client, asks something to the server, and server does the work and return it back. For example, there can be file server. Okay, there are a lot of files are stored in the file server. If I want, I can communicate with the file server and I get it. A lot of video server. Okay, videos are stored in the place, and if I want, I can get particular video from that. Right? So this is what they call it as a client server. For example, database server. Database server, it's very popular. All database programs are all data are available in one computer. We call that as a database server. From the database server, we can get some data. For example, how many students have got more than 200 marks in a particular subject. Okay, our total marks are more than 500 in an examination. So if that information is not available with us, we send that information to the database. Database server also will be having a program. That program will be initiated, and using that program, you will get the result, and server in turn will send you back the result, and you can utilize it. So this is client server internet phase. And all these things happened at this stage. Next, in fact, is again another big revolution. In fact, everything we can call that a revolution, right? There is you cannot put a lesser word in this, lesser word than this. Either invention of silicons, invention of personal computer, and invention of the client server, and internet, and similarly invention of this cloud, mobile, and big data, creation of mobile, big data, all those things we can term as a revolution. This is a third step in that. So if you take this mobile and smartphone ubiquity, okay, ubiquity means without you knowing that automatically the computation will be done. It's not explicit. Automatically, it is programmed to do it. For example, you are keeping your mobile phone in your pocket. It will count how many number of steps you have walked. Okay, how many number of steps you have walked. So this is one of the ubiquity nature. So the smart mobile phone and smartphones comes into the picture. It is being used for computations. It is used for doing some business process. Right, I can order something from my mobile phone. I can purchase something from my mobile phone. I can do the business transaction from my mobile phone. So all those things are possible in this time period. And so people were using a smartphone. People were using computers. Now there is a question comes. Okay, why do you have to purchase computers? Why do you need to purchase computers? Why do you need to purchase operating system? All of you know that computers means you should have an application program, operating systems. Okay, you should have also infrastructure like disk, memory, all those things. You don't purchase anything. he will purchase it, the cloud provider, we call them as a cloud provider. The cloud provider will purchase it and keep it with us. Okay, if you want, you use it and you pay for your usage. Right? For example, I'll give a best example how this cloud will be useful. In an organization, I require computer for computation of my salary. Even you take in your school itself, right? I need to print out a slip and I need to print out some GPF amount, all those things. That hardly takes 2 days for me. In order to use that 2 days, I need to purchase a computer. I need to purchase an operating system. I need to purchase a application software. For example, either I may purchase a Tally or I may purchase Excel software. So all those things I need to purchase that will be useful in a year itself, 24 days. That's all. Okay, I will not be using for anything else. It is very costly option. So instead of that, I have one small computer, right, which can access this cloud, in which I have all operating systems and application program, okay, utility program, all the programs are available. I will be using it and I can, I will be using it and I can do my work. And I only pay for whatever I have used. So this is an advantage. So it is always not possible to go for a very high-end machines. Okay, for example, in our institute, if we want to do some research, it is very difficult to go for a supercomputers or highly powerful computer. Instead of that, there are some big clouds or the high fast computing clouds are available. I just submit my job to them and it will be executed and the results will be sent to me. I don't need to purchase. My institution need not purchase such high-end computers. So these are the advantages of the cloud computers, cloud computing, and many advantages are there. In fact, you are accessing your email, right? And emails are there in the cloud. Okay, Amazon, it is a cloud. All the data are available in the cloud. So everything is now cloud-based computing. Right. Now, next is, as all of you know, that social networks. Okay, the social networks is very popular. Facebook, WhatsApp in this environment, and it's there. LinkedIn, YouTube, okay, Twitter, all those things are there. Okay, you know the purpose of all those things. That social network has evolved. And there are a lot of programs, a lot of advantages. It's not only just sharing some information. Whatever the information shared is also analyzed, and from that they have also come to a conclusion. It is also nowadays is being carried out. Okay, so that is social networks and big data. Now we have so much data, information coming from mobile phone, information coming from social networks, information coming from some other capturing devices. So when you have so much data, you need to process that such a big data. This is different from what we do it in a smaller data. Oh, so there are a lot of technologies have come to handle this big data, right? For example, if a product I want to find out whether it is how people have evaluated the product, what mark they have given the product. Okay, if they have assigned some mark, what mark they have given, what emotion they have shown in the Facebook. Okay, or in so those things can be analyzed, and from that I can find out whether it is I can go for the purchase or not. So this is a digital transformation. Now, this is the big data analytics. You can see this. There are a lot of things. Data are available from coming from all the streams, and it being analyzed for some purpose. I can take some decision. For example, whether I can open another bank. Right. For example, in Assam Silchar, some 5 or 6 banks are there. All the transaction data are coming. Now I can take a decision whether I can open another counter or I can open another branch of that. So that kind of these things it is there. For example, you take nowadays the best example is the corona, right? All the data are coming from people are transmitting from these things, and hospitals are transmitting from the computer. Okay. Transmitting from the computers, hospitals and the government offices are transmitting the data from the computers. So we can now evaluate it from all this data. We call it as a big data. We can come to a conclusion whether it will spread and what kind of prevention methodology one can enforce. And okay, so all those things can be analyzed and come to a conclusion using that big data. They call that kind of analysis, we call that as a big data analysis. So this is what information technology, okay, evolved up to 2010. You can see this, how it has evolved. One minute, now unable to go to the next one. Yeah, okay. Again, it has gone. Okay. Okay. Now we will see that. Please understand. First one is the mainframe and PCs. Next level is business process automation. Next is the mobile data. Okay, the cloud and mobile data. Now, how this is applicable with respect to a health sector? How this is applicable to with respect to a health sector? If you take health sector, these are the major functions of the health sector. Patient care, supply and disposal management, scheduling and resource allocation, hospital administration, hospital management. So again, for example, patient care, if you take patient admission, decision making, planning and organization of patient treatment, whether patient treatment requires only giving a medicine or doing some kind of a minor surgery or major surgery. So all those decisions need to be taken. Order entry, therapeutic nursing procedures, and coding of diagnosis and procedure, and patient discharge. So all similarly, you have to schedule also. For example, nurses need to be scheduled and staff need to be scheduled. And similarly, you have here cost accounting, controlling, finance accounting, facility management, information management. All those things need to be there. All are the functions of these things. Now, if you see this, correct? If you see this, whatever the evolution which we have seen, we'll take this path. Okay, initially you are having focus on automation. Domain is only administration. Okay, it is individual department wise. For example, outpatient department will have one computer. Okay, outpatient department will have one computer, and lab will have computer separately. So they may be processing it. They will be using a PCs and they will be processing it. How to annotate it? Anything I have to do extra? Sorry, this information. Anything I have to do extra for annotation? Allow annotation. Press the right arrow key to select it. Okay. Okay, now I have annotated. Just one. Okay. So you can see this. This is the individual department will be having computers, and they try to automate their own department work. Now, if you take this, okay, so they within this they have computer. Within this they have connected. Within this they have connected. 1 minute. Sorry, I let this now. Yeah. So they within this hospital, they could able to connect it so that lab reports is available and so on. Next is the professional development, okay, where some kind of network has been established. So here mainframe computers are there, and mainly it is used for administration. Here mid-range computers are there. It is being used by lab everywhere. And after that, they have started connecting all these computers, and that is the third phase. And fourth phase is the access of the information from the internet. If you see exactly whatever we have seen, this is being followed here. Whatever we have seen, this is being followed here. You can see that this is one of the health sector. It is being connected. You see here, this is a hospital. In the hospital information network, it is being connected here. All the computers are connected, and here through this GSM network, okay, it is getting connected to even patient's home. You can monitor whatever there in the patient's home through internet. You can monitor. It can be monitored by the doctor. And if some person has got some accident or something, it is very much possible to communicate to the hospital. And if it requires, ambulance vehicle also can be communicated so that they can come here and take the person, and either rural health center can be taken, or he can be taken to the hospital, right? So here the doctor who is on move can also monitor the patient, okay, through his unit or through his mobile unit. It is also possible for him to monitor this. So see, if you see this is a third phase, where it involves a big data, mobile utility. All those things all those concepts have come into this things in the health sector. Now we have covered this. What we have covered so far is how this has evolved, and some example for this. Okay, in the case we have seen some example. Now next one is the intelligent technology, right? This period we call that as a intelligent technologies, intelligent technology. Correct, intelligent technology. What is the theme is to create an intelligent enterprise. To create an intelligent enterprise. So what is that intelligent? Okay. So in order to understand this, we should start with artificial intelligence. I start with a very basic information about artificial intelligence, and we can see some examples of an artificial intelligence. In fact, this is the person who coined the phrase artificial intelligence. Is a John McCarthy. Right, he has coined this word in some conference. But before that itself, people were talking about the intelligence of computer program. For example, Alan Turing has conducted one test, right? So in that test, what he has done is one end, one person is sitting, human is sitting. On the other end, one human and as well as one computer program is responding. One human as well as computer program is responding. A program is termed as intelligent program if the person who is sitting on the other end unable to distinguish between man and computer program. Okay, so a person who is sitting at one end will be asking questions. Okay, or will be asking some kind of conversing with the computer, conversing with another person. That either the person will be answering or the computer program will be answering. If the receiving person unable to distinguish whether it is a man answered or computer program answered, right? Then we can call that program as a intelligent program. That's what he has conducted. He called that test as very popularly as an intelligent test. So the word intelligent is being used. There were also some kind of researches were going on, right? There are some branch of computer science concerned with making computers behave like humans. And actually, after that, the term was coined in 1956. That word artificial intelligence is coined by them. And 1974 described algorithm for AI programming on job. All of you be okay. It not only creates so much interest in other field, right? In the literary field also, it has created so much interest. These are some of the cinemas which has come based on the artificial intelligence. And this is again has come in Tamil Nadu. It's acted by Rajinikanth, both Yendiran as well as 2.0. So this is completely based on the artificial intelligence and robots. Okay, so what is an artificial intelligence? Let us discuss what is an artificial intelligence. It is a science and engineering of making intelligent machine, especially intelligent computer programs. Its task is using computers to understand human intelligence, ability to achieve goals in the world. AI is the study of how to make computers do things at the moment people do better. Okay? So human beings have
It's taking back the timing.
some capacity.
Come fast because it's not yet done, I think.
Is it okay? Is it okay?
From 9 o'clock, I told her.
Is it okay? Is it okay?
This mic is muted, so a lot of noise is coming.
Yeah, please, all of you, switch your mute your mic. All of you, please mute your mic. Is it screen visible?
Participants are requested to mute your microphone. Actually, we are getting lot of noises. Both the resource person and the participants are getting disturbed. So please help and continue the session.
Yes. Please mute your mic.
All the participants.
Yeah.
If you have any queries, please you can raise at the end of the lecture, please.
Okay. It is right. So it is we have some capacity to do something which up to that time the computer programs cannot do it. Now, why the computer programs can also do something like a human? They can also think like a human. They can also, we can make them to think like classify like a human. Okay, we can also make programs to plan like a human being. We can also make the program to work like a human being. So this is a basic idea of the artificial intelligence. We try to mimic the human beings. Okay, so that is the basic definition of the artificial intelligence. What is the intelligent behavior? Right, what that human is having that intelligence. These are the intelligence. Okay. These are the intelligent. Learn from experience, apply knowledge acquired from experience, handle complex situations, solve important problems when some information is not there, but still we will solve the problem. And also when there are so many things are there, we will decide what is the important and we will do that. React quickly and correctly to a new situation. Even when we drive a car, something suddenly a person comes in between. It's not a expected situation, but we quickly press the brake, reduce the accelerator, right? So react quickly and correctly to a new situation. Understanding visual images, for example, just by looking at it, we know whether it is a fruit, whether it is a mouse, whether it is a mobile phone. So we can understand visual images, process and manipulate symbols. When symbols are there, we know what it represents. Be creative and imaginative and use heuristic. Explanation, I'll just give it in another 2 slides. So these are some of the intelligent behavior human exhibits. Okay, not all human, right? Many of the human is supposed to exhibit all these behaviors. So why can't we make the computers also to exhibit this behavior? That is the basic idea of artificial intelligence program. Okay, so what are the branches of engineering and science which supports? Basically, first computer science, philosophy. Okay, the reasoning, the concept of reasoning is taken from the philosophy, mathematics, logic, algorithm, optimization. All those techniques are taken from mathematics. Cognitive science and psychology. Okay, how a human being thinks. Okay, how animal thinks. A lot of algorithms have come based on how the animal thinks. And for example, there are a lot of swarm intelligence algorithms are there for how bees are collecting the honey. How bees are collecting the honey, that has been studied and has been applied for something else. For example, to find out the shortest route. When there are so many places you have to visit, what is the shortest route I want to find out? Apply that honeybee algorithm. Apply that honeybee algorithm. So that kind of algorithms are available. Okay, so that is part is dealt by cognitive science and psychology. Neural science, model low-level human-animal brain activity. That is how the brain is working. Only I concentrate on how the brain is working. So based on that, I try to model that and apply this, and also linguistics. So all these disciplines are contributing to the. All these disciplines are contributing to the. All these disciplines are contributing to the AI. Okay, so what are the characteristics of artificial intelligence? It's a symbolic processing. Instead of numeric, it should be able to process the symbols, and also heuristic. It also based on a heuristic. What is a heuristic? Intuitive knowledge learned from experience. By using heuristic, we do not have to rethink completely what to do every time we encounter a similar problem. For example, I don't know, maybe you are from a different places, most probably from that area, Assam, right? So I think this NIT Silchar is in mountain, I heard. Suppose from that I want to go quickly to some other place, right? So what I have to do, depending upon the situation, I have already have experience of reaching some other place. Okay, so that will come into the picture. That's what we call it as a heuristic. Okay, the intuitive knowledge gained from the experience, we call it as a heuristic. The artificial intelligent algorithm apply this techniques. And also inferencing. Okay, from something we try to gather what really happening. Reasoning capabilities. Okay, that we also have a reasoning, inferencing, right? That's called inferencing. If something happened, why it has happened, what is that has initiated, what is the effect of it. Okay, we are analyzing this, we call that as a inferencing. Now next is machine learning. Okay, learning capabilities that allow system to adjust their behavior and react to changes in the outside environment. Okay, this is what we call it as a machine learning. And you are going to have a separate session, 2-3 sessions on machine learning. Okay, anyhow I'll also give something now. One minute. I'll switch it off. Yeah. So here, if you take, this is a AI tree, these are the different branches. See, these are the supporting. If you can see this, these are the supporting. Psycholinguistic, sociolinguistic, computational linguistic, cognitive psychology, philosophy, logic, robotic, image. These are the technical field. Image processing, pattern recognition. See, please don't think that image processing is already existing. Image processing is a concept which is already existing before even we introduce AI concept into that. But thing is, by including AI concept, we could be able to produce the better result. For example, I'll explain you. I can understand, okay, the face. I can recognize somebody's face. That's a human capability. We try to provide this without artificial intelligence technique. It is very much possible. Okay, by using only the parameters, vision parameters I could be able to do that, right? But introducing AI will make the high accuracy. So all these things, electrical engineering, you have got robotics, pattern recognition management, mathematics, statistics, all these things are something like a root of an AI. And what it gives is, these are the different areas of, these are natural language processing, automatic programming, genetic algorithms, speech understanding, robotics, game playing, intelligent tutor, all those things are different fruits or branches of AI application. You can consider it that way. So now let us understand the machine learning, because all of you must have heard machine learning, deep learning. Okay, it's a very important concept. It's very popular nowadays. At least we try to understand that concept in detail. Learning denotes changes in a system that enable a system to do the same task. Okay. So there is I have something. Okay. I know something. Now I have got something. I made some dish. Right? The dish has. Okay. I made a dish eatable. Right. So now it is changes in the system. Now I can do the task easily next time. That's what we call it as a learning, right? So that's what it says, that learning denotes changes in a system that enable a system to do the same task more efficiently next time. Last time I make a little difficult biryani. Okay, biryani I find it difficult, but when I do second time, I will do it very nicely, very quickly. Okay, so this is what we call it as a this things. Now, learning is constructing or modifying. Learning is constructing or modifying representation of what is being experienced. So my inner representation of something will get modified. Okay, for example, if I assume in Tamil Nadu, if you take temples, okay, I have a representation. Temples means large, tall structures. Same thing, if I go to Kerala, I can see that some ordinary houses like things will be available. Right? My changes. Right? So these things we can call that as a learning. So what is a machine learning? Machine learning refers to a system capable of autonomous acquisition.
इन्होंने क्या क्या कितने सारे तो मेल भेजे थे मुझे, देखिए बैनर.
What are the machine learnings? Where it can be applied? No human experts, industrial and manufacturing control, mass spectrometer analysis, drug design, astronomic discovery, black box human expertise, face, hard writing, speech recognition. The machine learning can be applied. Driving a car, flying a plane can be applied. For example, you don't require a driver for driving a car. Okay, unmanned car, you can use that. Rapidly changing phenomena, credit scoring, financial modeling. For example, credit scoring, right? People will evaluate your credit score before they give a loan. Bank will evaluate it. That frequently changes. So that can be very easily found out. And also diagnosis, a lot of diagnosis, cancer diagnosis, some lung disease diagnosis, brain tumor diagnosis, all those things can be also be found out by using machine learning. And also fraud detection, right? Fraud detection also can be found by using this machine learning, right? So if a person transfer from X to Y continuously, no problem. But the moment he transfer X to Z, okay, that is different. Then machine learning finds that this activity is completely different from the previous activity. Then he will interfere, ensure that whether he really that is a real original one or a fraud. Okay.
Excuse me, sir. Vivekanandan, sir.
Yeah.
Sir, sorry for the interruption, sir.
Okay.
Sorry for the interruption. Few participants are not on mute, sir. Can you please announce that once? There's lots of disturbance from their side.
Yes, ma'am. So, dear participant, please mute the phone. In fact, have this as an first learning. Am I correct? You are going to now undergo completely the week.
This Kamal,
So you
Sir
learn by
Verma, they are
experience.
unmuted. So please mute yourself.
Yeah, mute. So
Sir,
that
I request, sir, from the host side, they all be muted. Otherwise, they are disturbing continuously. Some are continuously busy on chat and disturbing. We are unable to understand the topic actually.
Yeah, I can do that, but I have to given freedom for asking some question. That's why I'm not muted
sir,
from the host side.
no, we can ask in the end, sir. Let them
Okay.
let them
Mugen
go
sir, you mute all the participants.
Sure. Okay, I will do that.
Shall I call out the
We
names
can
of the
have the question and
participants,
session
those
in
who
the
are not
last.
in mute?
Madam, from the host, you please mute all the mics.
Yeah. Okay,
Yes.
sir. Sir, I will mute. You can proceed, sir.
Yeah, if any questions are there, please note down. Note down, we will come back to that. Okay, shall I yeah.
Sir, please. Yes, sir.
Yeah, now all of you Amazon,
Can you please
correct?
tell me till what time this will continue?
1 o'clock?
Because we had teachers, we do have
1 o'clock, 1 o'clock. It will go up to 1 o'clock. 1 minute.
Yes, sir. You can
Yes,
please.
sir. Yes, sir.
1 o'clock or 1:05 or
Yes, sir, that's fine, sir.
Okay. See, the movie and book recommendation system, as soon as you enter Amazon, if you ask for something, it will give you a lot of things. If you ask for a particular book, then immediately it give you the other books which are related to that. Okay. So all kind of a recommendation system. For example, film recommendation system. Okay. So based on your interest, right, they try to find out what films are available at present. So all those things are very much possible by using the machine learning. By using the machine learning, it is very much possible. These are the application of machine learning. Again, this machine learning consists of so many other things. I'll do an example. Supervised. I'll just give you supervised label example. Okay, supervised label example. Yeah. So this is the supervised label example. These are the 3 parameters: occupation, age, loan salary ratio, whether he will repay the loan. Suppose I am a bank, I want to find out. I want to find out whether the person will be repay or not. How do I use the machine learning and the supervised learning method? These are the input all the input I'll give.
Excuse me, sir.
And yeah.
Sorry for the interruption.
Yeah.
Due to a lot of disturbances, we are not able to understand what you are teaching. I'll request the host to kindly remove that person if he or she is disturbing the entire class.
Yes, sir, we are not able to understand anything.
Kindly remove that person who was speaking in between.
Yes, sir, it is muted. Yeah.
Sir, we are not able to understand whatever is taught to us.
Yeah. Okay. Yeah, even some message is coming. Okay.
Sir, it is muted, sir. Please go ahead, sir.
Okay. Now, see, I'll just tell you what is learning. One concept called learning. Learning from the data. And it is called supervisory learning. For example, all this data with the label. We call this as a label. A person who is occupation is industrial, age is 44, loan and salary ratio as of now is 3.69, and whether he can repay it or not. Correct? This is the outcome. Now, I will give this to my learning program. It's nothing but a computer program. Data, I will give it to the computer program. Computer program will learn from this data, right? And after that, if a new person comes from the industry, age is 57, loan salary ratio is some 2.20, it will give me whether he will repay or defaulter. That's all. So this is the already existing data. From the data, the program learns it. From the data, the program learns it. And when I want to predict for a new data, right, it will predict it using the existing thing. We call this as a supervised learning because we have given here something here, okay, something here, labels. And also, for example, I'll give a unsupervised learning. I'll give my weight, my position, okay, age, all this data I'll give it. Okay, based on that it will group it. Based on that it automatically groups it. Right? Either OPSI weight, normal weight. Correct? It may be divided into 2 groups or it may be divided into 3 groups automatically. So this we call as unsupervised learning. Here we give the output and we train this. If these are the parameter, we can also call this as a feature. For example, here you have got 3 features. 1, 2, occupation is 1 feature, age is another feature, loan salary ratio is another feature, and we also tell that that fellow will repay. Industrial, age, and loan salary ratio, that fellow will repay. Okay, like that we will train the network. Now, after training it, I will give you the unknown data. It will tell me whether that fellow will repay or defaulter. Defaulter means who will not pay back the loan. That's what we call it as a defaulter. And similarly, here this one we call it supervisory learning. Unsupervisory learning means we never give this last column. We never give the outcome. We will give only the feature. It has to group it. It has to group into 2 things. One is a repay and another one is a defaulter. Assume that it will be trying to do it into 2 different groups automatically. This we call it as a unsupervised learning. So this is being widely used nowadays. In fact, you are going to learn in detail. Okay, very widely used, all these 2 things, and also reinforcement learning. It's based on the reward concept. Okay, if reward is being, if you achieve whatever you want, a reward will be given. If you don't achieve whatever you want, then punishment will be given. Right? So this concept is being used, okay, and we call that as a reinforcement learning. Similarly, there are other concepts of learning also there. So in the machine learning, you will be doing all these things, and also you are going to do using a Python program, all this some kind of a program, supervised learning, unsupervised learning, all those, you will be doing some real life examples. Okay, for example, a diabetics data will be given, and you will be able to tell that for a new person whether he will become diabetic or not. Okay, a heart rate parameters will be given, and you can say that whether that fellow will be affected by the heart rate or not. So how does it know? The program will learn it from the data. This is what they call it as a machine learning. Now, what is a deep learning? Just so you understand only what is deep learning, nothing else. Yeah, I have seen that bank example, and occupation, salary loan ratio, and age. These are the features. Using this feature, first in the machine learning part, you have to extract the feature and you have to classify it. For example, I have trained a program to identify whether it is a car or not. So in that case, I require to give the feature. What is that? It has got 4 tires. It has got a height of 1.5 meters. It has got a length of 3.5 meters. This we call it as a feature. If we give feature, we have to extract the feature. One more step is here necessary. We extract the feature, and after that we give it to the classification. It will say that whether it is a car. If it is a car, it will say car. If it is a lorry, then it will say not car. If it is a bus, it will say not car. Okay, so that we call it as a feature extraction. That is the machine learning part. But in the case of deep learning, we don't have to extract the feature. We don't have to extract the feature. We can directly give this as an input, and it will tell that whether it is a car or not. For example, you can just give a picture of this. It could be able to tell to us it is a car or not. Okay, so that is an advantage. One may ask, then and also the accuracy of deep learning is always high. For example, if you are giving the 100 vehicles, right, and it identifies exactly 90% of the vehicle machine learning, the deep learning could be able to identify 95 vehicles correctly. Okay, 95% accuracy. So when there is a great accuracy, why can't we go for always deep learning instead of machine learning? The problem is the resources. It requires a lot of resources. Deep learning requires a lot of resources. And another point which I want to tell is, for machine learning, you have got a lot of algorithms. Okay, a lot of algorithms are available, but deep learning is based on neural network, a concept called neural network. What is a neural network? Neural network is a concept which is based on how our brain works. Usually, the brain consists of neurons. Neuron is cell. Neuron is a cell which is there in the brain, and all these neurons are connected to understand something. If I touch something, that corresponding neurons are activated, and it will say that I have touched the table. If somebody speaks, I understand that language because that particular set of neurons have been already trained. That will activate, and it will tell that it will help us to understand what the other person speaks. Similar, the exact those things are modeled here in the neural network, and that has been used in the deep learning. So that is the basic difference between the machine learning and the deep learning. So in the machine learning, feature extraction is done. In the unclassified classification, in the deep learning, you don't need to do that. Machine learning, you have got a lot of programs, but deep learning, you are using only the neural network. Resources are very high here. Accuracy is also very high here in deep learning. Okay, so these are some of the terms which you have used. Now we will continue to see that. Expert system. For example, medical diagnosis, I can use some expert system, right? Which basically the expert system is built out of expert's knowledge. For example, doctor, what is his knowledge? All his knowledge are captured and stored, and it can be acquired in terms of question and session, and I can come to a conclusion whether a person has a disease or not. This is what expert system. A computer system that applies reasoning methodologies, knowledge in a specific domain to render advice or recommendations. Similarly, you have got natural language processing. In the natural language processing also, a lot of things are being applied. Speech processing also, the artificial intelligence is being applied. See, information technology uses all this concept. Okay, uses all this concept. Speech understanding, even I can now order something in the mobile phone, right? So basically, this is an information technology. So speech recognition is there already. But now we could be able to improve the accuracy by using the artificial intelligence. See, all this processing have been using without AI, but the inclusion of AI improve the performance in many ways. Please, you understand that. And robotics, it's a completely AI concept, right? Completely AI concepts. Okay. So machines that have the capability of performing manual function without human intervention. What is an intelligent robot? Intelligent robot has some kind of sensory apparatus such as camera that collects information about the robot's operation and its environment so as to interpret and respond to the change rather than just follow the instructions. It takes some decision. Okay, it takes some decision, right? Depending upon the environment, it takes some decision. That is the capacity of robot. Sensory system, basically again a vision system, which takes something. For example, ECG monitoring, right? ECG monitoring is monitored. That is being that signal is being processed, and anywhere the thing exceeds the limit. Okay, exceeds the limit, it gives the alarm. That's what we call it as a sensory system. Similarly, visual recognition system, I'll give some examples. Okay, intelligent computer-aided instruction, it is used, intelligent tutoring system, it is used in the education sector. Automatic program, in fact, program itself is created by using AI technology. I have told you about neural network. Okay, it is neural network is nothing but connection of neurons, right? Computer neurons. We call that also, that element which we model also called neuron. In our brain, whatever it is, that also we call as a neuron. So neurons are connected, and that is a neural computing networks. And similarly, game playing concept. Okay, how a person will play the game in general. Okay, so that is there also we are using the artificial intelligence, and along with translation also we have used, and we have got something called intelligent agent. Okay, always we can embed some kind of agent at some place, right? So we can have intelligence which will do something. For example, in our home, right? If somebody, we call it as an intelligent agent. If somebody goes some 2 or 3 times very frequently, then for example, in a bank where a person coming very frequently, then it identifies and do some kind of alarm. That is an agent, okay, which is looking for a specific action, which is a specific action. Somebody comes inside with a gun to the bank. What is only job is that the agent job is only to do that, for which we can apply the artificial intelligence. So all this, whatever we have studied now, AI and associated applications will made to have an enterprise which is intelligent, So if you take hospital, completely lot of AI has been applied. If you take manufacturing industry, lot of robots are employed, and if you take bank, there also they are using AI on all aspects of enterprise. Means it's an organization. So every organization they are using intelligence. That is basically now that is the phase we are at present. We are there. Okay, if you take health sector, we have seen some example of health sector. Okay, various things we can do it. Okay, medical imaging. From the medical image, these are some of the companies which are involved to create some product. Okay, create some product or doing some kind of services. So, for example, medical images you can use the diagnostic and mental health drug discovery. Okay, there is a process called drug discovery. You need to create a drugs. Okay, what is a drug? Drug is nothing but the molecules. All chemistry teachers will be knowing it. So when the molecules are combined in a specific way, they may serve the drugs, right? How to combine those? How to combine this? That where the AI comes into the picture. Okay, that's where the AI comes into the picture. Similarly, there are some lot of virtual assistant which will help you. Okay, even there are some assistants which will help the aged people. Okay, don't go here and there. It is there like that. Similarly, wearables. I can wear some devices in my body which intelligently find any problem, which will communicate to the hospitals, or which will communicate to me itself. So those things are also there. And inpatient healthcare emergency room, health management and monitoring, patient data and risk analytics. I have told about machine learning and all. Okay, machine learning. So using the machine learning, a patient is in a risk, or patient is having a particular heart disease or not. can be known from the medical image or from the other parameters one can find out. Okay, so all those things are, you see that this is a medical computer enterprise. The enterprise, we have got various functions need to be there done in enterprise, and all of those things AI can be applied. AI can be applied and can be made convenient. Now next is robots. Okay, display. I have already given a robot. Vision system, ability to learn and improve performance. Robot that can talk, walk other than on wheels. NLP response. Sometimes we need to respond in a natural language processing. If I say English, he should be able to understand. It should be able to understand, and also not simply carrying out the commands, but depending upon the circumstances, it need to change its course of actions. What are the places it can be? What are the places it can be used? Warehouses, pipes, bomb disposal. Am I correct? In bomb disposal, the human involving human is risky, right? Where we can put our robots. Okay, exploration of ocean floor or space, all those things we can achieve it. So you can see this number of Japan, 295 robots are there per 10,000 manufacturing human workers. Okay, Singapore 169, 164. You can see the different word. 86 robots are there per 10,000 manufacturing workers. Robot density, we call it as a robot density, number of robots employed per manufacturing 10,000 manufacturing workers. These are the domestic robots. All these things are AI concepts. AI is involved. AI programs are involved. Window cleaner, sweeping robots, surveillance robots, sports robot, all these robot accessories, all this robot, vacuum robot. Okay, all these things are there. Now next, this is a military robot. Okay, this is a humanoid robot. This is an AI in some assembly. It is used in assembly. Oh, something is repeated. So in fact, these are some robots. Robots can play the game. These robots will be owned by one team, and other robots will be owned by, this set of robots will be owned by the other team. Now they have to pass the ball and strike the goal, right? So here, usually in MIT, a Robo Cup will be held. It is very popular. So how effectively, say how you should coordinate between other robots of the same thing. They need to take some action. They have to analyze it. They have to do some action. So all those things need to be done. So all those things are there. Robo games. These things are used in space robots. So now what I'm trying to say is from the AI perspective, how the information technology changes. That's what I'm trying to say now. Okay, so that's why I have told initially, I have discussed many things without AI concept. Now, after AI, what are the changes that can take place? Okay, unmanned vehicle. Okay, unmanned vehicle, again, a very popular thing. Before Google car, it has come, right? So without, in fact, after people are telling that in 20 years, you don't require a driver to drive a car. Right, just you can sit inside and it automatically the system is available which can drive car, which uses the deep neural network. So deep learning, which is uses the deep learning, which uses the neural network. Similarly, chatbot. What is a chatbot? Yeah, I'll finish it within 5 minutes. 5 to 10 minutes. Yeah, chatbot is a computer program that simulate an intelligent conversation with one or more human users via auditory or textual method, primarily for engaging small talks. Okay, so what is the help? What is the use of that? Charter bots are often integrated into dialogue system for various practical purposes such as online help, personalized service, or information acquisition. Even if you take Amazon, initial chart is based on this kind of a chart bot. If person that say help desk person will come and talk. The initial thing basically based on a automatic chart bot. It is being used. In fact, one interesting thing, okay, is a Watson, which answer whatever you ask, it will answer. Okay, and in fact, there was a quiz competition between the people, two human and one Watson. Watson is a system which would be able to answer all the things, in which the Watson has won it, okay, one with a great margin, big margin, capable of answering question in a natural language. Competed against champion on Jeopardy. That thing is called quiz, not quiz. It's a Jeopardy and won. It has a one. It's some kind of a this kind of a thing. In that, it has won. That this machine has won. Okay, so these are the some of the structure of that. You can see that 16 terabytes of RAM can process 500 gigabytes in 1 millisecond, and content was stored in RAM rather than memory to be core easily accessed. Cost about 3 million. So in order to make that Watson, they have invested so much things to prove that it can answer like a human machine. Okay. Similarly, these are the sources it gets the information. Right? This one says how Watson works. AI in business, I have told, in business in many activity, whether we can give a loan, whether we want to start a new, whether we want to start a new branch, whether we want to start a new branch, new bank branch, whether we want to start a new supermarket, okay, what will be the trend, what will be the, who will vote for next government, okay, who will vote for the next government, and what will be my income, okay. So for all those things you can use in a business, you can use for all those things. In fact, this data mining is very popular because of the prediction, okay, predictive analytics, which has been adopted in the business, okay, for which we are using the data mining. AI in business, AI in vision system. What is vision system? You have here some kind of a camera to understand, capture the vision, and for processing and to take some action. Okay, as I have already told, if somebody enters, okay, or somebody moving in unnatural way, okay, all those things can be identified by these vision systems. We call it as a surveillance system. So for there we are applying the artificial intelligence. So in fact, you can say vision, we can face recognition, gesture recognition, space application, medical image analysis, autonomous vehicles. In everywhere we are using this vision concept, AI vision concept, we are using it. And sorry, it is a very small one. Yes, you can take this. And AI in education also, okay, for preparing course material, to evaluate the student, whether he is belonging to a high category or medium category or low learning category, okay, for our learner profile. This is what learner profile for everything. Everything we can give them, right? And also we can help him. Okay, he is particularly interested in one subject from his the traversing of lesson path, which he chooses from the computer database or computer web pages. We can always give the relevant material. We can identify and we can recommend systems. We can recommend. It's called recommendation system. We can recommend some good things to him. Okay, so this AI is also there, and Google and Yahoo. In fact, you must have understood that when we about to type, it will bring what is the relevant searches, right? So it also employs in a big manner this AI techniques, Google and Yahoo, particularly Google. Okay, so these are the some of the things. Okay, some of the things. So now let me recall what we have covered. We have covered what we have defined what is information technology, how it have evolved, and what are some of the sample information technology. In some domain we have seen it, and followed by some what is artificial intelligence and how this artificial intelligence from the perspective how this application, how this information technology will be helpful for various domains. Okay, that's what we have seen. So now the only thing is future trend. It can be many things, but few things which I have given here. Deep fake, for example, if it's Rajesh Khanna, okay, we can now create something where Rajesh Khanna can again act. Right, even though he's not there, I hope. He can. For example, MGR in Tamil Nadu, right? So he can. He already the people try to put him in some films for small duration, some short duration. Now we want to have more realistic movement of the MGR make. Okay, so that is called deepfake. Similarly, Trojans and voice spoofing. Trojans, all of you know that. Okay. Yeah. I'll adhere to the things, and another, as I have told, I'll finish it within 2 minutes. All AI Trojans and voice, auto ML tools, machine learning tools, which will help easy to do it, and federated learning. Sorry, learning is not a centralized learning. All this learning are defined in the centralized mechanism, but if it is to be federated, how it should be handled. Right. Okay. So with that, I complete it. I have also explained what we have summarized, what we have seen. If you have any question and if you have a time, you can ask me. Or otherwise, you can always ask me by email or my WhatsApp number. You can ask any questions in that. Yes. If you have any questions on any of the topics.
I guess it is
Federa was there. So what is Federa?
Sir, is busy with lunchtime, I think. You can always ask questions. You can have questions to my email. I'll pass that email, as well as any WhatsApp. If you have any questions, you can always post on this. The slides are available to you. Thank you very much. Thank you very much.
Yes, sir. So thank you very much, Professor Vivekanandan, sir, for sharing your valuable technical presentation about AI perspective. And I hope the participants are getting benefited. And from the organizer side, I heartily thank you for spending your valuable time and sharing your experience with the participants. So thank you very much, sir. So hope we'll connect in future also. Thank you very much.
Yes, thank you very much. Goodbye to all.
Professor sir, sorry for my delayed join.
It's okay, madam. It's okay.
I'll contact you later. Anyhow, thanks for accepting this, and you have given a very good lecture, and it's an eye opener for everyone. I think so. Thanks a lot, sir.
Thank you, madam. Thank you.
So thank you, sir. Thank you for sharing valuable information.
Mr. Shankar, the host.
Thanks a lot.
Can you hear me?
Yeah. I'll share the slides. I'll send the slides, madam. I'll send the slides. You can pass it on to the participants.
Yes. So, thank you, sir. So, dear participant, we'll break for lunch now. So, the second session of this FDP will resume at 2 o'clock. So, I request you join all the participants with the same link at 2 o'clock. So the next session will be computer system organization, will be delivered by Dr. R. Murugan from NIT Silchar. So thank you very much. See you again.
Sir, attendance. Can you get the attendance, sir?
Attendance will be recorded.
Attendance.
Yeah, madam. Attendance is the online attendance. We'll take it auto attendance from the WebEx. Don't worry about attendance.
From the WebEx. Okay.
Thank you.
Okay, thank you.
Every session there will be auto attendance from the website.
Sir, where can we get the presentation?
See, the presentation I will share at a time after the end of the day. I will collect all the session PPT, then I will share the PPT to all the participants through this email. Don't worry about presentation.
At the end of the FDP.
Yes, at the end of the FDP, I will share all the presentation PPT to all the participants.
Okay, thank you, sir.
Excuse me, sir. Excuse me, sir.
Yes, please.
Yes, we got the mail regarding the attendance that in the last session there will be a link shared in the chat box, and in that link our attendance will be marked. Is it so?
No, not like that. Like previously we planned for Google attendance, but now we plan for taking the attendance through WebEx. Don't worry about that.
Okay, okay.
Sir.
And what about the test, sir?
Test
What
will
about the
take
test?
the end of the day. End of the day.
It will not be done every day.
Yes, yes. End of the day we will take the test.
Okay.
And how long will
So the tests for the meeting be the same.
Sorry?
Credentials
for the test be
at 2.
Sir, exam will be at the last day? In the last day?
Yes, exam will be a last day.
Sir, will it be possible for you to share the PPT today? Revise for the test. Hello, Shankar sir. I would like to know how long will the link of the test be available?
Sorry, I did not get you.
Yes, sir. I'm saying, is it possible for you to share the paper test today itself? So that I can revise for the test.
Then you are not audible.
Attendance, sir.
Then you are not audible.
What about attendance? I'm asking regarding the
Attendance is the automatic attendance, sir. So don't worry about attendance.
Sir, nice. Thank you, sir.
Hello. Sir, I'm
Yes.
asking regarding the PPTs. Can you share them today itself?
Sir, because sending in the email to every 500 participant, we are exceeding our limit. I think you hope understand. So for avoiding those circumstances, I will send all the PPT at the end of the day to all the participants.
Fine, sir. End of the day, sir. That is
Yes.
fine with me. That is fine. Thank you, sir.
One more thing, sir.
Yes, please.
If there will be no test, then we'll get free by 3:30 then?
That today's session will be over.
Huh?
No, today we have planned only 2 sessions, madam. One is already over. The next session is 2 to 3:30. Then the today schedule is finished. Then you can join next day.
This is what I am asking. We will get by 3:30.
Today, yes, you will not be having any test today. So
Any
you will
test,
be free
no
from
test
3:30.
Yes.
No test today. Okay, sir. Okay. Thank you, sir.
Okay, thank you, sir.
How we have to fill the attendance?
The same question I am answering repeatedly, madam. The attendance will be taken automatically through WebEx. So don't worry about attendance.
Those who have attended the session, it will be recorded at the WebEx and we will take the attendance from it.
Yes,
It is an automatic process, so don't worry.
Okay, ma'am. Okay.
For artificial intelligence, is camera required or we can use any other physical signals also?
Camera, video is required. You are asking whether video attendance is required, right?
Thermal screening, infrared camera can also use that, also remote sensing. Thermal.
No. Don't think too much. It is like auto attendance. Don't think too
It
much.
is software related things, right? It is software related things and it is not like that. Okay. So if you once you join the session, it will be recorded.
Recorded
And
automatically.
from that we will be taking the attendance from that. So it is not related to any camera vendor, right?
Thank you, ma'am.
So thank you all. We'll see you again at 2 o'clock. Thank you.
Thank you all.
Thank you for the introduction. Good afternoon all. So let me share my screen. Is my screen is visible?
Yes, sir.
Thank you.
Yes, sir.
Yes, sir. It's visible.
Yeah, good afternoon all.
Murugan sir, 1 minute please.
Yeah,
Murugan
please.
sir. All the participants are requested to mute your audio. You can either leave the question in the chat box, otherwise wait until the presentation is over. You can ask your queries after the end of the presentation. Please kindly cooperate in this regard.
Yes, ma'am. because I'm the host, so I'm going to present the PPT. So I'm not able to like switch the presentation in between. So please cooperate, as Madam said. So please mute yourself and please enjoy the session. I hope it should be useful. Yeah. Again.
Sir, you can proceed. Thank you, sir.
Yeah. So the topic today I'm going to present this session is computer system and organization. So why I have chosen this topic for this, especially for this particular FDP track. So this topic, this is one of the subject for the CBSE students. So the syllabus, the content which I have prepared based on the CBSE syllabus. I think those who are teaching this computer science subject are going to teach computer science subject. So I think we may get some input from this presentation. Yeah, before getting into the topic, I want to share something related to my institute which I belongs. So I belongs to this institute, National Institute of Technology, Silchar. It is one of the reputed institution in the country, and it's one of the 31 NIT in the country. Basically, it was established in the year of 1967 as a regional engineering college in Silchar. Then later, it was upgraded as a NIT according to the NIT Act. So basically, this institute offering 3 degrees, basically undergraduate, postgraduate, and the doctoral degrees. So the degree awarded in all the engineering and science and humanities department, which are around 11 departments in the institution. So at present, the annual intake of the BTech program is around 700 members. And as a NIT, so NIT have state-of-the-art infrastructure facility, which includes the Kendriya Vidyalaya School, Invite, and their own kids school, and much more. And the NIT recently ranked by NIRS. It is one of the 47th rank. The NIT placed 47th rank among the engineering institution in the country. And I think virtually we are connected all over the country, but even I want to share some picture of this renowned institute. So this is the picture of NIT Silchar. Like you can see here, like a lot of greeneries you can see. The entire NIT campus is, I think you may see. And it is the natural beauty of Assam, and also the natural beauty of lakes and river, everything in and around the campus. And this is one of the NIT admin complex building. And this is another very historical place in NIT Silchar. It is a library of NIT Silchar. It is the name of this library is Bharatratna Dr. APJ Abdul Kalam Learning Research Center. So apart from that, I want to highlight something, some information related to the department where I'm working. So I'm working in this department, Electronics and Communication Engineering. So this department, we are offering 3 degrees to the students. So the first one is the BTech degree. The BTech, we are awarding the Electronics and Communication Engineering. And we are also offering 2 MTech degree. One is microelectronics and very large scale integration. And also we are offering communication and signal processing engineering. Then the 3rd degree, the department which offer is the PhD. So for the PhD, we are offering in all the specializations. Then getting into the agenda of the today talk, the topics to be covered in this today presentation is, which I highlighted in the slide. The whole topic, the whole syllabus I have taken from the CBSE syllabus. Say, for example, the computer system organization architecture is one of the basic course for the CBSE school students. So the topic which is given in the syllabus is one is like a basic computer organization. So in that particular topic, so we are going to discuss the fundamentals of computing, then how the computer can be assembled, and what are the physical property of the computer, and what is CPU, then what is the importance of memory, hard disk, and all things we are going to discuss in the first topic. And also I'm going to highlight this topic, which is types of software. Like we have any number of there are subdivisions or softwares are available, but even the major broad area of softwares are these three: application software, system software, and the utility software. So these softwares also we are going to discuss in this particular presentation. Then apart from that, we have like when you're talking about the computer organization, we always familiar in this the memory, like, because always the memory play a vital role for selecting the computer organization. Right? That is also we are going to discuss in this presentation. Then furthermore, we are going to discuss the Boolean logic. So this is also highlighted in the CBSE syllabus, especially for the computer science, like what is Boolean logic, how the Boolean logic can help to reduce the size of the computer. As you can see, maybe in the earlier days, the computer size are more, but nowadays you can see the computer size are getting reduced. So how it is possible? So because of this Boolean logic and also the state-of-the-art technologies. Okay, so the basic fundamental thing is that, so we have a lot of Boolean logic rules are there. So that is also I'm going to highlight in the today presentation. Then apart from that, the number system, the binary number system, decimal number system, octal and hexadecimal number system. So that is also I'm going to cover in this presentation. Then also the encoding scheme, like ASCII and other number system also I'm going to cover. Then these are the fundamentals of the computing platform, like a computer organization. Then again, apart from these are like fundamental, also the syllabus is highlighted the concept of compiler and interpreter. So I think at the school students, in the school student point of view, understanding these kind of terms very difficult. But even though the teaching community, so our duty to convey this particular concept as easy as possible. So that is why I have chosen this topic also in the today presentations, like what is compiler, what is interpreter, and those fundamental concepts. Then in addition, also I'm going to cover the fundamentals of operating system. So what is the need for an operating system for using this computer organization, and also some introduction, some examples also I'm going to highlight in the presentation. Then finally, the CBSE syllabus, they have covered some of the recent technique, the technology like cloud computing. What is cloud computing? Then what is cloud service? And also what is blockchain technology? So where these technologies are used. So that is also I'm going to cover in this particular presentation. Yeah. So the prime objective of this particular presentation is we'll discuss the computer organization and the structure, and also we have to familiarize with the units, measurements of related to the computer system, and also the objective is that we know the computer is the layered system, right? So what are the layers are there? Then obviously when you're talking to the architecture of the computer, so how the computer can be organized. So what are the basic architecture behind in that? So I'm going to highlight the very famous architecture of a computer, like the von Neumann architecture, then Harvard architecture, and those kind of fundamental architecture also. See, the basic overview is that the topic of this particular session is computer organization and architecture. Okay. Then why we have to study the computer organization and architecture? Okay. So that is very famous that is importance while before learning into that. So what are the reasons behind that? So the first thing is that for studying or learning the computer organization architecture is that design a better program. So that is always we have to develop some good program. So to design the better program. So how to design a better program? Once we know the existing design, then only we can able to design some more new program. Okay, so that is why. So the duty is to learn the basic computer design and architecture. So the thing is that why we have to go for it? Design a better program which includes a system software such as compiler, operating system, and device driver, much more. I think these terms are very common terms in computing environment, like a compiler that I'm highlighting in this furthermore slide. What is that? And the operating system which help to interact with the computer, like then also the device driver. The device driver means that the couple of computer programs that we have to be enabled or interface with any other applications. So that is also one of the reasons why we are learning the computer organization. Okay. Then another reason is that optimize the program behavior. See, if you know the computer organization and architecture, then obviously we can improve the behavior of the program. Okay, so how to improve the behavior of the program? So this is one of the technique, like we can optimize the program, then obviously we'll get a better behavior. Then another reason is that evaluate the computer system performance. Like if you have some computer, like how to evaluate, like the system is producing the optimum performance or not. Okay. For evaluating purpose also, so we need to go for this. We have to learn from this particular computer organization and structure. Okay. And apart from these three reasons, so obviously as the computer user, so we have to understand the timing. So the timing in the sense, see, suppose if you have a good configuration of the computer, obviously the runtime is very less. So if you are not having that kind of facility or the specification of the computer is not up to the level, then what happens? That we will be face some lot of complexity in the timing. Okay.
Excuse me. Can you please mute everybody? Please mute everybody. Kindly mute everybody. Sir, you can go ahead now.
Yeah. So, apart from these three reasons, like the timing, as I said, then timing play a vital role for analyzing the performance of the computer. Suppose if you have the good the specification, like your computer have a good specification, obviously will not face any timing constraint. But if not, then what happened? It will affect the timing. Then after that, we have to concentrate on space. If you have the updated system, obviously you will take less space if you occupy. Then obviously otherwise it will take more space. Then also the price trade-off, like it affect the cost also. Okay, so these are the reasons basically why we have to study this computer organization. So that is very, very, very important point. So these are all the main reasons behind that. Right. Then after this, like the basic principle, like behind in the computer component is that we know that while learning about the computer organization, so which include both hardware and software, right? But in general, anything can be done with software, can also be done with hardware, and also anything can be done with hardware and can also be software. This is the universal statement, so which we have to know about the computer component if the assume the speed is not a concern. Like anything will be doing with the help of software and hardware. Yeah. Then with this principle, if it is moved to the computer components, so at the basic level, maybe in the beginner's level, like the computer is the device which consists of three pieces, three major parts. Like we know, like even though I'm highlighting, so these are all the main three, basic pieces like for the computer component. One is that the processor to interpret and execute the program. Like so, in every computer, we know that the processor is there. So this processor is going to help, to execute the program. So this is the heart of the computer component. Then another component is that memory. The memory to store both data and the programs. Like always, if you want to save something to the computer, so we have to depend on the memory, right? So this is also the another component in the computer. Then third is that like the mechanism for transferring data to and from the outside world. Say, for example, if you want to transfer the data from your computer to the outside environment, so what we are doing, so we have to use this USB drive or CD drive, whatever it is. So those kind of transferring mechanism also is one of the important computer components, like from the basic level. See, like with this theoretical background, like I want to highlight some of the basics of computer like component or the computer specification, whatever it is. See here, I was given one advertisement in this particular slide, right? So if you go for the procuring or buying the computer to the market or the computer shop, you will get this kind of couple of specifications for that. See, suppose if you want to buy some new computer or old computer, so basically we have to check the component first, whether the component specification is optimum or not. Okay, so for understanding those computer specifications, I want to highlight some component here in this particular advertisement. See here, this is one advertisement for sale of a computer, maybe very cheap, and they have given some performance. Say for example, the Pentium 4.20 gigahertz, they are given one specification. So as a computer learner, as a computer beginner, we should learn what is that, what is means that the Pentium 4.20. And also they have highlighted some of the specification in the same 400 megahertz, 256 MB, DDR, SDRAM, so and so on. So this particular slide, I'm going to explain you like thoroughly what is the component which is each and every one which is highlighted in the specifications. Say for example, like before getting into the specification, we should know the measure of capacity and speed. Okay, so this is very, very important while analyzing the the computer component. Say for example, in the computing environment, if we call it as this term kilo, like if it is simply call it as K, so the kilo means that it is 1000. So mathematically we can return this is 10 power 3. Okay, and otherwise we can write 2 power 10 also, both are same. And also in the same way we can like measure mega, 1 million, 10 power 6, a giga, a tera, peta. So these are all the measure capacity and speed basically. So this is the fundamental we should know like before analyzing the specification of the computer component, like kilo, mega, giga, tera, peta. So these terms are common, but we know in our day-to-day like experience. So these are all the terms we are already familiar. But I'm going to explain how these terms can help to understand the computer component. Okay. Then, apart from this memory, we should also know the heads. No, heads we know it is a frequency unit, and in terms of the computer component, the heads equal to clock cycle per second. Okay, so for example, if 1 megahertz equal to, as you can see, there's like 1 to 0 to 0 hertz. Like this is the basic conversion that we know everybody. And if you are, as I told you, the processor is one of the major heart of the computer component. Basically, the processor speed can be measured in terms of megahertz or gigahertz. So this is the idea. This is the idea we should learn from this frequency. So normally, how we have to measure the processor speed? So in terms of frequency, the unit is in terms of megahertz or gigahertz. Okay, then after that, the byte. Say for example, if we have the if that we have the enough processor speed, then also we should understand the we should know the storage capacity of the particular computer or component, whatever it is. And we know byte. Okay? So the computer memory, which is represented in terms of byte, you know, the unit of storage. So the 1 byte, say for example, you know, normally we call it as bit. So the bit is, as you know, and we can call it as byte, and 8 bit is called byte, and also this byte can be represented in terms of unit 1 kp or 1 mp and so on, right? And also the byte can be measured for the main memory, and what are the external, if you are going to use some disk storage or the internal storage, whether it can be external storage, that also we can measure in terms of the byte, gigabyte and terabyte and all the things. Okay. And also we should know the time and space related to the computer component, like for example, milli, micro, nano, pico, and femto. So these also, you know, like as we are the teacher, we know these kind of, you know, measurement very well. But even though I'm highlighting, why? Because for better understanding of the component. The same way, you can say millisecond, nanosecond, what is micron, and all of them. Because these all measurement is going to help for the understanding of the computer component. Now, coming to the specification which is given in the advertisement. Right? So, for example, one computer specification, it is given Pentium 4.20 GHz, for example. So, what is means that? So, what we have to understand from the specification? It means that in terms of the computer component, we should understand the Pentium. It means that it is a processor. Okay. So, for example, the Pentium is the processor, and it will run at 4.20 gigahertz. So, what is mean by Pentium processor? Pentium processor means that in a computer, the microprocessor is the heart of the machine. Say, for example, the processor means that the technical name of that particular processor is microprocessor. Okay. And you know, the microprocessor is the brain of the system, and it executes the program instruction. This one is the Pentium processor, which will running at 4.2 gigahertz. So this is the exact meaning of this first specification. I think you hope understand. So for example, Pentium 4.2 gigahertz means that it's a Pentium processor, like it is one of the microprocessor, right? Which is fabricated by the very famous processor company Intel. The Pentium processors are fabricated by the company Intel, and also some other companies also fabricating this kind of processor, like Motorola, Zigzag, you know, and so many companies are there. But even in the computer market, Intel processors are very famous. But the idea is that Pentium 4.20 means that this is the microprocessor is began with that. And also you can see the another specification in the advertisement which I given, 400 megahertz. So what is means that this particular? They have given 400 megahertz, 56 MB and so on. Like, so the 400 megahertz means that a system bus move data within the computer. That means that, so the bus means that it's a couple of wires. Like say, for example, in a computer, we have n number of buses. Buses means that the couple of connections, couple of wires. So normally, all the computer, the component, we are connecting via buses. So these buses, how much it will, execute the output, how much time it will take, how much speed it will, to execute the data. So that is the main idea for it. Normally, the 400 megahertz means that the system bus can move the data within the computer, and the faster than the bus is better. Then this one's run at 400 megahertz. So the speed for executing the data in the computer is that 400 megahertz. So this is it. And as I told you, the microprocessor is the heart of the machine, the computer machine. But how it may be looking like? So you can see here some basic microprocessor I given in the slide. Say, for example, in a computer, if you open any computer, the component, I think you may find this kind of n number of like integrated circuit, maybe the processor inside the computer that you can find it in the motherboard of the computer. As you can see here, so in a motherboard, one heart is there, one heart of the integrated circuit is there. That is called processor. Like this is, we call it as microprocessor, and this is fabricated by many processor companies. And this is one processor, microprocessor, and so you can see here, this is the basic integrated circuit. The microprocessor means that it is a single chip integrated circuit. So it is having 40 pin dual inline package. So for one simple integrated circuit, we have 40 pin connections. So in each and every pin connection, it will be connected to the other processor, other computer component. But this whole integrated circuit is, controlling all the computer components. So while looking itself, it is very small, but the use of this microprocessor, the purpose of this microprocessor is very huge. This is the basic, the microprocessor, one of the basic microprocessor in that. And we have various versions, numbers for the microprocessor based on the memory. Here it is highlighted. One is M5L 8085AB. It means that it is 8085 microprocessor. And this kind of number you can find from the above of this particular integrated circuit in all the ICs. It may be placed. Yeah. So now coming to the specification of that particular advertisement, and so the first two things we have understand, like what is the processor and also how much time that particular system can help to transfer the data. Then apart from that, so we have to understand the memory system. So the memory system, which means that there are three variety of memory systems which there in a computer component. Like one is the large main memory capacity. Normally in a computer component, we have the memory capacity that is like the huge memory. That is, we call it basically normal, the large main memory capacity. So it may run the program, the larger program with greater speed than computer having a small memory. And also the another memory which belongs to the RAM. To the measurement of the speed, can be analyzed with the help of this particular memory, which is called RAM. Normally we call it as RAM, right? Nothing but random access memory. So this is the random access memory, which means that the time to access the content is independent of its isolation. Suppose if your memory size is more, then your booting speed will be more, and the processing time also more. If your RAM size is very less, then obviously the performance will be less. And also the another memory, which is the cache. So it is a temporary memory like that can be accessed faster than the RAM. So for example, you may say the cache memory. Suppose if you are frequently typing any word in your computer or browser or wherever it is, what happens? The cache memory, it will store temporarily, then it will be enabled to avoid those, the typing platform. So for example, if you're typing one link in the browser, maybe one URL in the browser, for example, Google. When you're typing to the G, you will get all the history, which will be stored in the temporary memory. If you type G, you will get google.com, Gmail, and those things. So this is basically the cache, the temporary memory. That is also the part of this particular computer component. Okay. So now from this fundamental, if you go for the other specification of the computer, which means that like 256 MP, like they may given like this TDR, SD, RAM, like this. So it means that it is mentioning the RAM speed. Like say for example, 256 means that the system has 256 MP of synchronous dynamic RAM. So SD RAM means synchronous dynamic RAM. So the size is 256 MP. And also another specification we can find from here is that 32 KB L1 cache memory. Cache means that it has the 2-level cache memory, the level 1, and this particular level 1 cache smaller, and it may be faster than the 2. And the main understanding is that the size is measured in the KB, in the 32 KB here. So this is the understanding of the this is the information we should understand from these specifications. So what is the RAM? What is the size of the cache and other things? So the other specification is that the hard disk size. Say for example, if it is given 80 GB serial ATA hard drive, means that the hard disk capacity, that is the amount of data which we can going to store in the computer. Okay, so here this particular specifications, this one can store 80 GB, the whole memory, and 7,200 RPM is the rotational speed of the disk. Okay, so generally the faster disk rotate and the faster it can deliver the data. That means the many factor involved, but even this particular specification, that 80 we can store up to 80 GB with the rotational speed of 700 RPM. So this is the another information we are learning from this specification. And you can see here a lot of acronyms played in this particular specification. That ATA means that it stands for Advanced Technology Attachment. So which describe how the hard disk interface which connect with the other system component. So they are going to connect with the the technology. Like normally it is that what technology means, that may be indicated here. And also you can see the another specification from here is that 48 cross CD or DW. That means that what is that? That means that every computer system we have the CD RAM, right? CD, DVD RAM, right? So this is the specification. Like a CD can store up to 650 MB of data. This drive support rewritable, whether it can be writable or read or whatever it is. And also how much the speed, the 48x describes the speed of the particular computer, that drive. And the another specification which we learn from this is like 8 USB port. That means that normally the port which is having in computer we have the n number of ports, but this particular computer they have total 8 USB port we can connect, one serial port, one parallel port facility is available. Okay, so that port can help to allow the movement of data like between the internal and the external. Suppose if you want to transfer the data from your computer into the hard disk, external hard disk, or maybe the USB drive, so this port you can help, you can utilize for the transferring purpose. Okay, so this thing is that, so these many ports are available in this particular computer. Okay, and apart from that, some other specification also you can find is that the bus. As I told you, the bus, like how many buses will be connected from the system. So that also you can highlight, it may be highlighted in the specifications, like 56K PCI data and other the modem you can connect, and 64-bit PCI. That means that peripheral computer interface. Okay, so these are all the bus you can directly connect from this. Then apart from this, the monitor, the size, and how much time it will take for refreshment, and what is the video card, that audio card that may be support from the system. So these many information you can find from the specifications, right? So I think I am highlighting almost all the computer specifications. So suppose if you want to buy a computer, if you want to analyze those computer components, so these are all the techniques behind in that. Okay, so blind away for purchasing a computer is not advisable. Before like buying a computer, so you should analyze the specification thoroughly, and also you have to evaluate the performance of the particular specification. Then only you will get some good computer that we can purchase, right? So apart from this, like my another direction of the presentation is that which include this computer organization. We talk about the historical development, right? I don't want to take much more time in this historical development because this is completely theoretical background, but these things are available in in the text itself, right? So a lot of the historical development is there. For example, the first invention computer, it is a room in size, but nowadays you can see with the help of the technological development, now in our smartphone itself we have the computer, right? So how this is happened, like, so what are the technology behind in that? So while the invention of the computer, like the integrated circuit, that means that IC size is more, like, but now with the help of the electronics technology, like you can say the technology VLSI, like very large scale integration technique, the technology can help to reduce the size of the integrated circuit, like so those technologies can help obviously to reduce the size of the computer. But before invention of this particular, before invention of this integrated circuit, basically we have the transistors, right? With the help of the transistor, so the hardware complexity is more, then only the size of the hardware component is more. So that is the basic conclusion while learning from this historical development. And just skipping this kind of quickly for the historical development. Say for example, the computer historical development, we call it as the generation, right? Generation 0. For example, the mechanical calculating machines are invented from 1642 to 1945, and we have n number of versions like the Pascal machine, difference engine, and Charles Babbage. So these kind of historical things which is we know, and even though the first generation the vacuum tubes are invented, so the vacuum tubes, like, it will take more space, that is why the size is more. And when we go for the second generation, the transistors are invented. So after the invention of transistor, again the computer size is getting reduced. And when we go for the third generation, as the IBM has invented the first integrated circuit for computer in the year of 1965 to 80. Obviously, this is the revolution of the size miniaturization techniques. So obviously, the size of the computer getting reduced. Okay, and again, when we go for the fourth generation system, as I told you, the VLSI computer, the VLSI technology came into the picture. So obviously, this VLSI can help to more than 10,000 computer per chip. Imagine that. Okay, so we can fabricate n number of transistor in a single chip integrated circuit. Okay, so that is why the revolution is happened. That is the size of the computer was getting reduced, and nowadays again this VLSI technology can help in terms of the processor. Even one microprocessor, 140-pin microprocessor can control the entire computer. Okay, so that is why in our a simple smartphone also, like working as the computer. So we have one processor, that whole processor will control the whole machine. And even this is one part, like the technology, like the VLSI technology can help to reduce the size of the memory, but size of the hardware. But even though apart from the technology, so many scientists, they have invented like many techniques to reduce the size of the hardware. Say for example, this is one very famous law in computing environment, which is called Moore's law. So this is the Moore's law can help to the density of transistor in an integrated circuit will double every year. Like the law, it states defined like that. But this law, with the help of this law, what we can do, the transistor, I mean the integrated circuit, that can be reduced. No? That is one thing we can learn from this law. And the another version is that the density of silicon chip double every year, every 18 months. Okay, so that is also the density. The help of density also, so we can learn. Obviously, this kind of laws can help to reduce the size of the component. Okay, and not only for this Moore's law, but also we have another famous law, especially for the cost. Say for example, the Rock's law. For example, the cost of capital equipment to build semiconductor will double every 4 years. See here. So with this, that, and 1968, the new chip was funded about not $12,000. Now imagine, but now it is very cheap because with the help of this Rock's law, like the cost also getting reduced every day. That is why we are getting the computer in every home with affordable prices. Okay, and this is Rock's law also pointing the same. Okay, and this is the very short the deliverables which is related to the historical point of the computer, because these things like we learn from our past experience. I'm just skipping in a very fast manner. Now after that, I want to highlight some of the hierarchy of the computer level, which is also the part of the computer organization and architecture. Say, in a computer, say for example, in a computer level hierarchy, say suppose if you want to write some computer program, right? So how the program can be how the program can be running. That is, we can learn from this particular presentation, the level of the hierarchy. In general, the writing complex program require basically the divide and conquer approach, which is a very famous approach in the computing environment. So for solving the smaller problem. Okay, and the complex computer system employ a similar technique though a series of virtual machine layers. Say for example, if you have a smaller problem, then you can go for divided conquer. And also for the complex problem, also the similar kind of techniques which is available. Okay. And you can see here one picture I was given in the presentations, like for better understanding of the computer level hierarchy. Say for example, the first one is that in a computer level, there are total 7 hierarchies there. Say for example, the first one is that level 0 to level 6, which means that digital logic, control, machine, system software, assembly language, high-level language, and the user language. As you can see, I am just take a little bit of time for explaining this computer hierarchy. I think it will be help for better understanding of the participants. Say, for example, the level 0, the digital logic. Say, like in overall, when you are looking the outside, it is a machine. But when you are going to analyze the inside of the component, basically the circuit and gates are the logic gates are playing in the computer, right? So this is the digital logic. This is the logic. This is the first hierarchy of the computer. Okay. So once the circuits, gates, everything is fine, then we move on to the level 1. That will be control for all the circuits and gates and all the parts, inner parts which is present in the digital circuits. Okay, that we can use the microcode or hardware. that we can use for the controlling purpose, right? Then the machine, in terms of level 2, the instruction set architecture. Normally, if you want to write some program or something, what happens? So we have to use the instruction set that we have to place in the level 2. Then, if once the instruction set is available, then we have to go for the system software. System software means that what we have to do, so we have to control, we need some basic interface to connect all the digital logic, control machine and everything. Like suppose if you are typing number 1, so what happens? This will be going to the instruction level. So that we have to pass into the digital circuit. So how it may be possible. So we need some basic interface that will be called as like an operating system, which will help to communicate all the system component. Then also we should know the assembly language. Suppose if we are writing some external program or something else, so that we can write with the help of these languages, assembly
Excuse
languages.
me, sir. Sorry for the interruption, sir. Shankar, sir, 1 second. Sir, one candidate, Bhavani ma'am's video is on, sir. Can you ask her to switch off? Bhavani ma'am, please switch off your video, ma'am. Yeah, thank you. Do that, thanks. Thank you, sir. Sorry for the interruption. You may continue.
Yeah, no problem. So, even the system program is there. Suppose if you want to write some special program, for some specific applications. So obviously, we have to use these assembly languages based on the processor, which processor we have used in the digital logic. Okay, so there we have to use the assembly code. Like this is the one kind of level. It's the 4th level. Then apart from the assembly language, this assembly language can be for the hardware purpose. Say for example, if you are installing some driver or device driver or something else, that we can use for this assembly code. And apart from that, the other language, the high-level languages, that is also will support in the computer level IT. So that is in the level 5. So normally we know the high-level languages, C, C++, Java, Fortran, and many languages, that is high-level languages are available. So these 0 to 5, the 6th level, this obviously going to be used by the user. So that all the languages, system software, everything, so that may be in terms of the executable program. Okay, then only the user can be benefited. Okay, so that these all the instructions, so we have to convert it to the executable file, and the file may be used by the user. Okay, so this is the overall computer level hierarchy. Basically, we followed in the computer system environment. Okay, so I'm almost highlighted all the things in the like the diagram itself. For the better understanding, I am given from level by level in the slides. I think this I can skip because I have explained in the diagram itself. And yeah. So after this hierarchy, I am just moving into the computer architecture. So up to now, we have learned the organization, like computer organizations. And now from this part, I'm just highlighting the computer architecture. So the architecture means that, so we know the major component of the computer is central processing unit, that is the CPU, and memory, peripheral devices. And also we have the, this component can help for making the architecture. It consists of internal structure and also interconnections, okay, which will help to speed and width of the particular processor. Okay, and as you can see here is that the simple computer machine organization. So here the simple organization machine, which is consist of the control unit. Okay, this control unit can control all the levels. Say for example, the first one is a ALU, that is a block which is arithmetic logical unit. That is one, a unit in the particular computer, and this is can control by this particular unit. And also the memory, the memory in terms of data memory and in terms of instruction memory. So both also can control. Then also the control unit, it can control with input and output devices. So for example, we are using keyboard, mouse, and monitor. Those kind of devices also controlled by the control unit. Okay. So this is a basic, simple machine organization. Okay. So for a simple computer, this particular technique will be absolutely fine. So what happens is that suppose if you want to increase the memory size. Say for example, what happened in this particular simple machine organization, only data memory is there. Say for example, if you want to increase the memory size, what happen automatically? So the system complexity will increase. So based on that, so we need to increase the the specification, increase the size of the particular memory. So what is the technology behind in that? Okay. So what is the architecture behind in that particular computer machine? So that I'm going to highlight in class. So basically, this is one of the basic architecture model which can help to build a computer system which is known as von Neumann architecture. Okay. So this is one architecture basically we use in all the computer. So for example, the von Neumann architecture is highlighting that. So we have the main memory. So the main memory we have on one side, and also the CPU is connecting the central processing unit, which is connecting to the main memory, then which also connect with the interfacing unit with ALU and the control unit. Okay. So with the help of this particular process, we can connect to the input and output system. But even in more technically in central processing unit, we have a couple of register, program counter, stack pointer, and all the hardware which is inbuilt in this central processing unit. Okay. So this is the basic model of the von Neumann architecture basically we used in the computer. Okay. But now in the computing environment, the von Neumann architecture is getting modified because nowadays the speed and in terms of memory, the von Neumann architecture will not help for the future generation computer. Now that is why what happened is that the another architecture has developed the name that architecture, the name is that Harvard architecture. Okay, you can see here in that. So I am just pictorially represented in this particular slide the difference between the von Neumann architecture and the Harvard architecture, right? So for example, the first one is that von Neumann architecture. So if you have the memory like program memory and data memory, so we have both memory in a single block. So the processor, they have to communicate with the memory. So what happens is that the size of the memory is more. Automatically, the processing speed will be very less, right? For avoiding those critical, the critical things. So the hardware architecture they have developed. So they have separated the program memory and the data memory. So for example, if you have the two parts, one is the program memory and another one is the data memory, then what happens is that the processor can communicate simultaneously both data memory as well as the program memory. So what happens, sir, is that this particular architecture can help to speed up the process, okay, when compared to the von Neumann architecture, because the von Neumann architecture, both are in the single block. So what happens, obviously it will take time, but if you use the Harvard architecture, what happens is that it will speed up the process. Like we can simultaneously, we can collect the data from both data and memory, okay. That is why our modern, all the smartphones are built with Harvard architecture. So that is why our the modern smartphones are very fast. Okay, very fast. You can whatever you want, you can get the nanosecond. It will get the data. It will retrieve the data. Okay, so this is the basic architecture behind in the computer environment. Yeah. So once the architecture is ready, right, then obviously we need to concentrate more on the software. That is also the part of the computer architecture. Like so, basically in computer hard or software divided into two. One is the system application and another one is the application software. So the system applications means that it will inbuilt in the computer, like that particular whatever the application we are going to use, that will be inside the computer. But the application software, it may be outside the environment, maybe outside the computer. Say for example, the system applications, again, we can divide it into three parts. One is the operating system and the language processor, and the third one is the utility software. So the operating system, it is the the fundamental software which we need for all the computing environment, okay, to control, to help, to connect, all the hardware. and also the software, no? And the language processor. Say, for example, if you are using some like processor or the microprocessor, that we can write to the corresponding language. So then only the processor will support. So that is one kind of application, system applications in the computer software. And the third one is the utility software. So normally the utility software means that it will help to secure the system. Say, for example, we'll use this virus, antivirus in the computer. Right? So this antivirus can protect your computer. So this is basically called as the utility software. Sorry. Then apart from the system applications, so we have the application software like general purpose application software and the specific purpose application software. So the general purpose application software is that, say for example, if you are going to use this web browser, okay, so that is mandatory, for all the computer. So this is one kind of application. Like the general purpose application software is required. Say for example, if you are downloading Google Chrome, Mozilla Firefox. So these are all the general purpose application software that may be help for the user. And another one is that the specific purpose application software. So the specific purpose application software means that, say for example, most of the teachers are here. So here, suppose if you want to take the attendance, like the automatic attendance for your online classes. So what you have to do? So you have to use some specific software, right? So those software is called specific purpose application software. In the morning class also, I was addressed some few queries from the participant, how we are taking the attendance, right? So the attendance I'm taking with the help of the specific purpose application software, which I am using. So I'm using the software like WebEx. It can help to, to do the automatic attendance. Okay, this is one kind of just example for the specific application purpose software. Okay, so these are all the major types of software which is normally we face in the computing environment. Okay. Then next, after the applications, now I'm quite concentrating something more about the architecture. So when you're talking about the computer architecture, so keep this computer every day, the computer size are getting reduced. How? So this, what is the basic principle behind in that? So basically, this is the first technique, the foremost technique while reducing the computer size and architecture, everything, which is called the Boolean logic. Okay, so the Boolean logic is invented by the very famous scientist Boolean. Okay, so he have developed so many Boolean laws, like the principle, to reduce the digital logic. Okay, and these are some of the Boolean logic which I have present in the slide. Say for example, not and NAND or NOR XOR XNOR. So these things we may learn. I think this is very basic things. Everybody knows that. So these are the basic Boolean laws we invented. Obviously, these Boolean logic gate can help to build a digital circuit, and also it will help to reduce to the complexity of the digital circuit. So, for example, is that this is the basic gate, and apart from the Boolean logic, which you can say here, if it is the AND gate, say for example, AND logic. So this is a symbol behind in that. So AND means that, so we have to run the operator A into B, okay, A dot B. And if it is the OR gate, it's the basic symbol for the OR gate, but the mathematical equation behind in that A plus B, okay. So not only this AND OR, but also NOT, NAND, NOR, XOR. So these are the basic operator. So with the help of this operator, so what we can do, so we can specifically we can design our own digital logic, or otherwise this logic can help to reduce the available existing logic. So the both way it is possible. Okay. Then apart from the basic Boolean logic and some other Boolean laws also he was developed, like the laws can be called as consensus theorem, identity element, complement, distributive, commutative, okay, and identity element. So these are all the laws also we derived. Okay, so these are all some of the basic laws which we have. And with the help of this law, say for example, I want to highlight how the logic can be minimized. Okay. So for example, one consider this equation AB plus BC plus B plus C. Okay, so this is one digital logic. Suppose if you are going to use this Boolean algebra or the Boolean law, so this particular logic can be minimized. Say for example, this from this equation to we can reduce, we can simplify this equation. For example, B into A plus C. How? So we have to sequentially apply this Boolean law. For example, by applying identity principle, like we can say A equal to A. Before that, we can apply distributing element. So you multiply this BC with each side, we'll get BBC and BCC. Okay. So here two similar items are there. We apply the identity principle. So what we'll get? So the BB will get B. So we can write it BC plus BC. And again, you can apply the same identity. So this can be simplified as AB plus BC. Then finally, both B's are common in these two terms. Then we write B of A plus C. So now you can see that from the long one equation 2, we are simplifying these equations. So in that way, this Boolean logic can help to reduce the logic as well as reduce the size. And another example which is I given in this particular slide is the logic expression. We can derive, we can simplify with the help of the Boolean logic. Okay. So from this equation, F equal to A dot B dot C plus A bar plus A dot B dot plus C2. So we are reducing just A bar plus C while applying, keep on applying this Boolean logic or law, will reduce the size of the equation, right? So in that way, this particular law, I mean the Boolean law, can help to reduce the, to simplify the logic. Okay. So this is the basic techniques behind in the size miniaturization as well as the memory requirement. So once while talking about discussing about this the digital logic, in terms of computer architecture, we should also learn the number system, because all these computer architecture, so we have deal with the numbers, like the numerical values. So that is also one of the important topic in while learning the computer architecture and organizations. So the number system also play a vital role while representing in the logic. Say for example, the decimal number system, binary number system, octal number system, hexadecimal number system. So these are the four major category of number system which is commonly used in the computer architecture or the computing component. So for the better understanding of the number system, so normally the decimal number we can call it as base 10, and binary we usually write in base 2, and octal number system we normally write in octal 8, and hexadecimal in terms of 16. Okay. And so these are all the the base we can use to represent the respective number system: decimal, binary, octal, and hexadecimal. Okay, so the idea which is we learn from this particular number system is that, so for example, if you have the decimal number system, so suppose if you want to convert into binary number system, because the computer environment or the computer system organization can help to convert from one form to another form with which is based on the user need, or it may be based on the application. So for example, one application they may use decimal number system, maybe some other they may use for the binary number system. What happens is that, so the computer can support all the variety of number system. That will also support the conversion from one part to another number system. So that is also very important in the computer architecture. So these four number systems also, so we have to inbuilt in this all the computing architecture. So how to convert it? What is the mathematics behind in that? So we have a couple of mathematical procedure to convert from one form to another form. Okay, if we have the facility in the computing architecture, then only the architecture will be produce some better performance. Otherwise, that will not get some optimal performance. So for example, one example which is I'm given in the slide, which is conversion of binary number into the decimal number. Okay. So the binary number, we know that it is represented in some of zeros and ones because it's a binary number. Okay. So 1 0 1 0 1 0 1 1 0 1 1. This is a long binary number, right? So from the binary number, if you want to convert into the decimal number, the normal decimal number, then how to convert it? Okay. So that we have to learn the procedure. It is a basic mathematics behind in that. So if you know the mathematics, then obviously you should can easily convert this decimal number system. So not only for this binary to decimal, but also the other conversion also. So we have a number of mathematics principle that as a teacher we should learn all the things. For one understanding, I have given like this example. The same way you can develop the another number systems. So how to convert from one to another. Yeah. So up to now, I have highlighted almost all the computer fundamental, peripheral, and architecture part. Now we are moving into the hardware part. Say, for example, the concept of compiler and the interpreter. So here there are two terms, two hardware behind in that, like two concepts behind in this technique. One is the compiler. So basically, how the compiler is working. Okay. So the compiler or the interpreter are the program basically that help to convert the high level language into the machine code to better understanding of the computer. So for example, if you have a compiler, the compiler is helping to convert from the source code like to the machine code. Okay. And this is basically called compiler. And when we go for the interpreter, the interpreter work is very simple, which will deal both like the machine code conversion, which is also in the interpreter unit, so that we can it will convert from source code to whatever the output we want. Okay, that based on the requirement, based on the user requirement, it will convert in terms of nanoseconds. So these are all the two basics concept which is began in the computing environment, the compiler and interpreter. Okay, nowadays both these concepts are using in the computer architecture, which depends on the like computer. And next time moving into the concept is called the operating system. Like we know the operating system, like it is an interface to connect all the computer hardware and software. See here, while concentrating on the computer, we have all these particular components. For example, like hard disk, mouse, printer, keyboard, monitor, and any other applications. So those things. Okay, so these all the hardware are controlled by the controlled by the interface. It's called interfacing, which is called operating system. Okay, so the operating system is one of the major part of the computer in any computer architecture. So basically, while developing the operating system, that should support for all the computer components. So in the present scenario, we have n number of good operating systems are available in the market. Say for example, Windows, Linux, BlackBerry, Android, Debian, OXX, iOS, BSD, FreeRTOS. So these are all the very famous operating systems. It's mostly widely used by the people. This depends on the hardware. Suppose if you're using some mobile, you can use Android, iOS, and the same way Windows, Linux, other operating system also used by the users. Yeah. So next, I am moving into the another concept which is called cloud computing. Like the cloud computing means is that basically it is defines that it's a delivery of different services through the internet. Suppose if you are using the internet, okay, so the main platform for the cloud computing is that internet. So without internet, we can't do this delivery for different services, right? So the internet is the basic source for this cloud computing. it is defined as a delivery of different services through the internet. These resources include tools, applications like data storage, server, database, networking, and software, and much more. Okay, so assume this is the cloud computing environment. As you can see here, the cloud computing basically will support three basic architecture. One is the infrastructure, platform, and applications. So with the help of these, facility, it will connect to all the computer, like the devices. It may be a desktop, it may be a laptop, it may be a phone, laptop, or server, and much more. Okay, nowadays, these all kind of with the help of the internet, all the application software are using with the help of this cloud environment. Say, for example, morning Professor Vivekanandam said that Amazon, right? The same way, if you use this online shopping like Amazon, Flipkart, all the things, it will be support for both the web as well as applications, everything, right? So these are the cloud computing software applications so that you can use in any devices. It can be a phone or laptop or desktop, whatever it is you want to use. Okay, so this is the basics of the cloud computing that can help to share the resources in terms of storage or server, database, and much more. Then after this cloud computing, I want to highlight one more techniques. It is like a technology, like a blockchain technology. So the blockchain technology defines is that it's the structure that store the transactional record. Say, for example, if you are using the online transaction, right? So I'm highlighted the online transaction process here. So say, for example, then I will tell you how the blockchain technology can help. See here, for example, when you're going to perform the online transaction, the user can request the transaction, right? Then what happens if the block can be represented in terms of transaction created, and it will pass into the information to the broadcasting. Then it will note to the identify the corresponding node. So what account you want to transfer the money or whatever the transaction. Then the block, what happened? The block can be identified. Then it will be added to the chain. Then you will get the verified message whether your transaction is success or not. Okay. So these are all the step by step, the sequence of steps from transfer from money from one user to another. Okay. So here the technology is that. Say here you have one server, and this server can connect to the broadcasting and to the correct another bank server. So how many process which is involved here? So here basically lot of databases are involved, right? So these databases can connect with the help of the chain process. Okay, and this chain process is connected to the peer-to-peer node, the peer-to-peer network. And finally, the storage is referred to the digital ledger. Okay, it is like one kind of ledger. Say, for example, before the, say, for example, the online banking system, how we are withdraw the money. So we have to go to the bank, we have to write a slip, and the banker, they will write your, page, how much amount you have, then they will make a note of it, then deliver the cash. But now with the help of this technology, it is very simple. Automatically, your transactions are maintained by the digital ledger. So how much balance you have, what time you have to withdraw the amount, everything that will be, maintained, with this, digital chain. Okay. So this is called basically this technology.
So
we call it as the blockchain technology. Okay. So this application also like very important in the current scenario in the digital environment, because we have used all the this online transaction, whether it can be through the internet or it may be through the web, or it may be a application software or whatever it is. Okay, but wherever, so this technology is going, this help us to maintain all the the transaction details in a digital form. Okay, so this technology, which is called blockchain technology, so this is also a very famous technology in the present scenario. Okay, so up to now, so I am covering all these topics which is given in the CBSE syllabus of computer system organization and architecture. Okay, and the conclusion for this particular talk this particular session is that I hope this lecture has given an complete overview of the subject, computer system organization and architecture. So I was delivered from the basic level because my objective is to cover all the topic which is given in the CBSE school syllabus. So I hope this may be benefited to the participant. So from this, I'm concluding the session. And if you have any queries, any questions, so you can write a mail. So my mail ID is given in the slide, murugan.rmn@ec.nitslc.in. So I think I have sent some couple of email to all the participants. If you have any doubt, any queries, please feel to write. I'm ready to help you. So thank you. Thank you. If you have any queries, please.
Sir, please do share the presentation after this session.
Sure, sir. I will share the presentation. It is not a big deal. Yeah, it is not a big deal. Sure, I will share it.
Sir, good afternoon. What about the attendance, sir? Attendance sheet?
Madam, attendance will take it from the online. Okay, please.
Okay, like we are attending the classes, so you will take the attendance.
Yes, yes.
Okay, thank you, sir. And test will be happen on the last day only.
Yes, madam. Yes,
sir, at near about what time?
Sorry?
Timing of the test? Yeah, evening timings only, no? After the class?
Yeah, after the class. Yes.
Oh, okay.
Murugan sir, a question in RAM. The RAM slide, you said that the time to access content is independent of its location.
Yes.
I didn't get that point. Under RAM, time to access, under the RAM slide, time to access contents is independent of its location.
No, it is not like that. It is based on the size of the RAM. Say, for example, if you have the higher memory size of the RAM, what happens is that it will help to retrieve the memory very quickly. Okay, so that is the basic idea behind that.
Okay. So it is nothing to do with the time to access the content, right?
Yes.
Okay. Thank you, sir.
Sir, one clarification.
Sir,
how many tests do we have?
good afternoon, sir.
Hello, can you hear me, sir?
Yes. Actually, I'm getting some 2-3 voice at a time.
The thing is, I'm just one clarification.
Yes, sir.
How many tests we are having in this 5 days?
Sir, the whole 5 days, only one test, sir. That will be conducted at the end of the day.
That is on 30th, it will be conducted at 2 o'clock.
Yes, sir.
2 o'clock or 3:30?
No, that after the end of the session, after 3:30 to 4, the test will be conducted. Then after the test, 4 to 4:30, the valedictory ceremony has.
Okay, so all these 5 days, we are having only one test on the last day, that is on 30th.
Yes, sir.
Okay, thank you so much, sir.
What will be the total, sir?
Sorry?
So we don't have any tests, sir?
No. Today we don't have any tests. Only the end of the day.
Thank you.
Sir, what will be the timing for tomorrow to start?
Madam, tomorrow the session will be as per the schedule which is we have shared, right?
Sir, we have got multiple schedules. Is it at 9:30 or 11?
9:30, madam. The session will start from tomorrow onwards, 9:30.
Okay.
Sir, but the updated schedule says it is at 11 o'clock, sir, every day.
No, madam. The updated no. The schedule that I have shared the updated schedule. That is the last one. Like, don't confuse the earlier one because they have some confusion.
Sir. In that updated schedule only.
Please. I will finish. Then you can ask.
Okay, sir. Okay, sorry, sir.
Because of this, the inaugural ceremony, so we have some. We have changed the schedule. But from tomorrow onwards, there is no confusion. The session will start from 9:30 sharp from the rest of the days.
Sir. Hello, sir. Do we have any mark limit to get for the test?
Yes. We have some threshold.
Excuse me, sir.
Excuse me, sir. Can we
Yes.
end the meeting?
Yes, madam, you can.
Okay, sir. Thank you.
The session.
Can we have a WhatsApp group regarding this FDP?
Sorry, sir, it is not possible for WhatsApp group because we have number of participants are more. In one WhatsApp group, the 250 are limit, but it is not possible for this many participants.
Sir, how many we are here? What is the total number of participants?
No, that is not duty to say, sir. Sorry.
Okay, no problem.
Sir, every day the last session will be like this. 3:30 will be the end of the sessions.
Yes, madam.
Thank you, sir. Thank you.
And sir, examination will be in the last day or
Yes,
in every day, sir?
Last day.
Last day. Sir, on the timing of the examination?
Last day, 3:30 to 4.
3:30 to 4. Okay, okay, sir. And it will be in how many marks and in what format, sir?
The test will be online through Google Form.
On Google Form. How many marks, sir?
That we have to decide.
Okay, sir. Okay, sir.
Excuse me.
Yes, please.
Sir, where can we check our attendance?
Sir, don't worry about attendance. You attend the session. Attendance is not a part of you. We will consider the attendance. Why you are repeatedly asking attendance?
Okay,
if you are attending the session, automatically the attendance will take it from the like WebEx software. Don't worry about it.
Oh, the software. Okay.
Madam, please conclude.
Excuse me, sir. Excuse me, sir. Am I audible, sir?
Yes, yes,
sir.
you are audible, sir.
May we get the PDF of these workshops or not?
Yes, yes. You are talking about presentation.
Yes, yes. I'm talking about presentation. Yes, sir.
Yes, sir. You will get the presentation at the end of the day.
Okay, sir. Thank you so much, sir. Because we are not capturing all the presentation, whatever you are showing
problem,
us.
No problem. Both the way, we will support you. We will share the PowerPoint presentation at the end of the day. And also, this all presentation videos are recorded. It will be uploaded in the NIT Chilcher YouTube channel. The link I will share later.
Okay, sir. Thank you so much, sir. Thank you so much.
Excuse me, sir.
Hello, good afternoon.
Sir, just
Hello, good afternoon.
Yeah, I just wanted to know. Are we going to have something on quantum? Or is it limited to AI?
Yes, this objective of this workshop is only for AI.
All right, thank you, sir.
Hello, good afternoon, sir. This is Ramashankar Divedi from Chintal Salo. Hello, sir. Good afternoon. Yeah, sir, can you provide, sir, PPTs and all the e-grant so that it is used for us?
Sir,
yeah.
So the same question, how many times I have answered, sir?
Okay.
This is very simple, sir. This will be shared at the end of the day.
Okay. Thank you. Thank you very much. Thank you very much, sir.
Can we leave the session?
Yeah, you can leave this. Suganya, madam, please conclude. Madam, you are not audible. Suganya, madam, you are not audible.
Shankar sir, required for computing. Logical controlling is required for computing. How we can visualize this thing? This logical computing are in a network process. Did you get, sir? Logical computing is required. We are simply giving operations OR gate, AND gate, and NOT gate.
Sir, your voice is breaking. Please write your question to the email. Sure, I will answer your question. I'm not getting, so you are continuously breaking. So thank you, all of you, all the participants. So up to this today's session is over. Then the next session tomorrow, it will start at 9:30. Okay, the topic which is going to present in the tomorrow first session is that the importance and applications of office tools. So that will be delivered by our own colleague, Dr. Srijit from Electrical Engineering Department, NIT Silchar. So I hope all of you to join the link which is we have already shared to your email, the day 2 link. So sharp at 9:30. So thank you very much and see you
Murugan
tomorrow.
sir, thanks a lot for your wonderful session. I have
Thank you,
so
ma'am.
much with my laptop, so I am again joining with my mobile.
Okay, ma'am.
So, dear participants,
Thank you, sir. Thank you for your explanations. Thank you. Thank you very much.
You whatever the thing you want to tell, you just leave in the chat box, right? Otherwise, you can contact Murugan sir through email. The repeated questions are, you don't worry about that. Please don't post these same questions for the further sessions. Your attendance will be recorded and it is taken from the WebEx. You don't no need to worry about this, and all the presentation slides will be shared to you at the end of the FDP. Right? So these two questions, and this is for all the sessions. From tomorrow, the session will start. First session will start by 9:30. Second session will be start by 11, and third session will start by 2. And the each day it will be ended by 3:30. You will not be having any test in between. You will be having the test only at the end of the session. That is the end of the FDP by 3:30 to 4 through Google Forms. We'll let you know how much marks it is before the day. Say maybe 29th. Okay. So these questions are repeated questions. Please don't post the same questions again and again. I request all the participants for the same. Murugan sir, thanks a lot.
Thank you, madam.
So we can leave the meet. Thank you all.
Link for first. Hello.
Tell me, sir.
Conducted.
Tell me, please. Tomorrow's link is already shared in the mail.
The link for attendance.
Link for attendance, there is no separate link. Once you log in the WebEx through your mail ID, it will be recorded in the WebEx itself through software. So we will take the attendance from the software automatically. It is automated.
Talking about the session on information technology AI perspective, it is what conducted or not? The session just after the
session already 11 morning by 11 12 it has been started and it ended by 1:05. Morning it has been over.
But I didn't find the link for the same in my mail ID. It was only for the inauguration session.
For day 1, same ID only. You are logged in to this session. You have logged from one ID, no? Same ID for the previous session also. For each and every session, we are not sharing the ID. For a single day, you will be having only one ID.
ID. Okay. But ma'am, I didn't find the link for that session actually. That's why.
Now, how you joined? This is the link for the same.
At 3 o'clock, 2 o'clock, ma'am. But I didn't find the link for the session just after the inauguration. Information technology and AI perspective.
Same link.
I didn't.
You have joined now, no? The same link for the previous session also. The full day, for the full day, it is single link only.
Please provide the video share for that session, ma'am. I didn't attend that session actually.
Video will be available in the YouTube, NIT Silchar official YouTube after the FDP. You can watch later. We will share the link to you, YouTube link. Okay.
So if everything is fine, we can leave the meet and we'll join tomorrow morning 9:30 a.m. sharp. Thank you all.
Hello.
sir.